So in this example video, we will be solving the rational equation on the screen. Now, like any rational equation, when you are solving it, the first thing you should definitely do is make sure you copy the problem down correctly. The next thing you should do is analyze all of your denominators. We want to make sure all of our denominators are factored if they aren't factored already. If you have linear expressions in your denominators, those are essentially prime, unless you have a GCF of a constant. For example, 2 could be a GCF, right? But you can't be pulling out an X or anything like that if you are dealing with linear factors, of course. So we are looking at our denominators here, and we want to make sure that our denominators are all, in fact, factored. So the first two look pretty good, but I still need to make sure I factor that third denominator at the right side of the equal sign, all right? So more often than not, let's not play dumb here, right? We should be aware of the fact that it's probable that the factored form of the quadratic expression over here is going to require you to use those two factors. Don't jump to conclusions, of course, but always, use those numbers to get yourself started. Let's not dilly-dally, right? So maybe I'm being a little lazy and I just factor it right underneath the quadratic trinomial. So x, 5, and 9. Now I just kind of start with that, and if I have a negative 45 at the end, that means I have one positive number and one negative number. So the signs in the middle are going to be opposite one another. X times x is definitely x squared. 5 times 9 is definitely 45. I'll start with two negatives because we could always change a negative sign into a positive sign or a minus into a plus. Although I watch students erase minus signs to write plus signs all the time. Why do you guys do that? Now, outer is 9x and inner is 5x. In order to get negative 4x, right, you have to pass along that negative gene. So the bigger number has to be negative, more dominant there. So I'm going to make the 5 positive. And cross-check that with what we started with. Amazing. It's exactly what we wanted. Great. So maybe I can lightly cross this out with an X so I don't get distracted by it. But we don't want to totally scribble it out because, sometimes you have to read things, right? Now, the next step when you're solving a rational equation is, of course, to multiply everything through by your least common denominator. Remember, your least common denominator, the phrase least often confuses people. Least common denominator is a more specific version of least common multiple. Multiples are when we count by something. Multiples of 12, like 12, 24, 36, 48, and so on. Factors are the pieces that create something. So factors of 12 are like 1, 2, 3, 4, 6, and 12. Those are the numbers that can be used to multiply to make 12. So your multiples are often bigger, even though we're saying least common multiple or lowest common denominator. It's just because we don't necessarily need to go to 48. If we're going with the 12s, maybe we just want 12, maybe 24, 36, the lowest one. We don't necessarily need 48 or 60 or 72. Sorry, rambling. But my least common denominator, this has an x plus 5, this has an x minus 9, and this has both. Well, it's going to be the one with both, right? We can give our denominators more by multiplying on top and bottom if we were to be actually finding a common denominator and doing it that way, but we can't take things away. And if we give both in the multiply through step, we are more or less ensuring that every fraction will no longer be a fraction. We will clear out all of our denominators. So I'm going to be multiplying both sides by x plus 5 and x minus 9. A little squish, so forgive me for that. Now, nice and slow. If this gets multiplied in here, right? This whole little package, whoop, this guy right here gets multiplied by this guy right here. Please don't be the person that has to write out x times x plus 5 times x minus 9. Let's distribute, expand, FOIL, blah, blah, blah. No, don't be crazy. You are doing this with intention. X plus 5 will cross out with x plus 5. That means that the x in the numerator only needs to concern itself with multiplying by the x minus 9. Minus, I'm going to keep my minus signs lined up so I know where I'm working. 2 on top. When this goes back, I know the x plus 5 reduced before. It was gone, crossed out, but it's back. We're distributing, right? So x plus 5 is there while the x minus 9's reduce because x minus 9 on top and bottom is 1. Lovely. So 2 only needs to multiply by x plus 5. Equal sign right underneath. Now, again, my numerator, all numerators and denominators have invisible parentheses around them. So there's that numerator. And when I multiply this in, oh, amazing. All of my denominator crossed out. Well, I don't know what those parentheses are for now. Nothing. So next step, well, it's a little lopsided, but let's keep it moving. We're going to open up these parentheses so we can look at this, which is now going to be a polynomial equation. So we have x squared minus 9x, that's this, minus 2x minus 10 is equal to negative 11x plus 15. Since again, it's a polynomial, we're going to get everything to one side. We're going to get this equation equal to 0. We're going to factor. If it's factorable, it's a quadratic. Even if it's not factorable, we can use quadratic formula. We're going to use zero product property to solve if it's factorable. And like I said, quadratic formula if not. So what do we got here? X squared. I'm going to combine like terms. This is negative 11x and minus 10. And then I have another negative 11x here and a plus 15. I want to get a 0 on this side, so I'm going to add 11x. While we do that, since I do have an 11x on either side, interesting, I'm going to subtract 15 while I'm at it. Subtract 15. This is canceling because canceling creates 0. And then this is x squared minus 25 because this also canceled. I know you can add the 25 over and take the square root of both sides. Problem with that, however, is that more often than not, people will, when taking the square root of 25, only put down the positive square root of 25. However, if you solve by factoring, you will factor this using conjugates because we're dealing with the difference of two squares. When we use zero product property, we're setting each factor equal to 0. X minus 5 equals 0. Cutting it off the page, sorry. And that means x equals 5 and x plus 5 equals 0, which means, bring that over, x is equal to negative 5. So we got these two answers right down over there. What is it though that we always need to remember to do? If you said that we always need to remember to, I'm not doing this correctly at all, that we always need to go back and check for our restrictions or excluded values, then you are absolutely correct. So we want, I'm so crooked today. I'm sorry, everyone. I want to make sure that these solutions are allowed. Are they valid? So if we go back to the original equation, you also want to consider the factored form. What is it that x is not allowed to equal? Well, here, if x is equal to negative 5, I'm going to get a 0 in my denominator. So that is definitely not allowed. And if x is equal to 9, I also get a 0 in my denominator, which creates an undefined situation. So that's also not allowed. So now these are restrictions over here, right? Restrictions, that'll be my abbreviation for right now. And then these are solutions algebraically, but ... we need to eliminate. So because x can't equal negative 5, and I did get that, this one is an extraneous solution. It's an extra one. Doesn't work, disqualified. And this one right over here is the actual final answer. All right. So there you have it. So if you got this as your answer, bravo, good job. I'm proud of you. 5 is fine. You could always plug it back in and just make sure it works in general, but you should be good to go. -5 again is extraneous. These are the solutions we found algebraically, because remember, when we solved our rational equation, it had transformed into a polynomial. Polynomials are smooth and continuous. The domain is all real numbers. We don't run into any obstacles. Rational equations, they have restrictions. If you were to graph a rational equation, it has a vertical asymptote, or so maybe multiple, maybe it has none, but more often than not it does. So, because of the adjustments we made while we solved it, we may get extra answers, and it is what it is. All right. Hope this was helpful. If you need more practice or to check over more examples or anything else, just check this playlist. And I hope you feel like you're a super genius now. All right. Have a great day.